This is the fire we know. But these are the fires that kill. Fires are slow fires with no flames that release toxic and often lethal gases. They can go for a while without being detected, and they're responsible for about 25% of all fire deaths in the United States alone. This is where I study. My name's William, and I'm a fire scientist at the University of Waterloo, well, a student. That rusty thing on the right side of the red building is about 2 stories tall, and those silver cylinders on top of the red building are very powerful fans to pull out the smoke in that building when we're doing experiments. A couple weeks ago, I was doing an experiment. I was burning about a cookie sheet full of peat. I went in about halfway through the experiment, donning my protective gear, of course, and flies were literally dropping from the sky. They were dying of carbon monoxide poisoning from a smoldering fire. Imagine what came out of this mattress. They're dangerous, but so what? Well, 1 in 10 space shuttles have had charred wires. Charred wire incidents. You might wonder what that means. This is a charred wire on an automobile. You can see the wire that the hand is holding. It's burnt, it started to smolder, and it could have started a fire. It starts fire on Earth, and it could start one on the space station. Thankfully, no fires have been started in space, but it is still a risk. A NASA safety briefing reported that these kind of ignition sources, arcs, sparks, and wires, happen all the time. Well, often. And it's something that does start a fire. It's a big risk. Fires in space are absolutely catastrophic. There's absolutely nowhere to go. Now imagine a world where space travel is as common as flying to New York or Edmonton. $1 billion industry. I'm looking at you, Virgin and SpaceX. It's your job. We need to understand how these fires behave in space so we can learn to detect them and put it out. Well, after a lot of reading, I have discovered that these kind of fires are not well studied in zero gravities, smoldering fires, that is. The best we have done is a small sheet of paper like this. Doesn't tell us much. To find out something, we have to burn something like this. And that will give us good information. But no one in their right mind would let us do that on the International Space Station or any manned mission. Remember this? So I looked into building a CubeSat that would allow us to do this in space. The BurningSat has no risk to human life because we can't fit on one, and so much valuable information could be gained. It would cost about $12,000, $13,000 to buy the components. Total weight comes around 50 kilograms, and it would consume about 120 watts of energy at any given time. And everything would be relatively small. Yeah, relatively small. All off-the-shelf components. You could go to the store and buy these. So it's completely doable. It would carry 4 blocks like this to do 4 experiments, and they would be, they would look like that on it. They would be positioned in such a way, and you would be able to perform experiments independently on the blocks. And this would allow us to get that much closer to understanding more about these mysterious smoldering fires. We would find out how to detect them as early as possible in space and here on Earth. What we learn up there would not only be useful for the explorers of the final frontier, but also on our planet. Scientifically, these experiments would give us a simpler case to study. Removing gravity as a variable would allow us to simplify our models, and this would allow us to understand or to focus our attention on smoldering mechanics, which are so poorly understood. Back to Earth. Fires on plane usually start out as smoldering fires. In fact, charred wires like we saw on the space shuttle. What if we could detect smoldering fires before they cause a major problem, before the plane has to do an emergency landing? How about at home? There's 2 people I'd like to thank, especially, apart from everyone else. One is Heather Fraser over there, a fire suppression going to Fire Technology, who has helped me a lot, and the other one is Ross Gillette, who has helped me a lot yesterday, and without them, this presentation would have been possible. Thank you.
Okay. So how would you smolder in your CubeSat? Well, how do you start the smoldering?
Well, since we can produce these samples chemically, I was thinking of putting a nichrome igniter at different locations within the foam. So you could actually start it from the center and see what kind of effects you would see on the outside initially in the fire. Or you could put it on the outside. You could also build in thermocouples to measure the temperature.
So do you put sensors all over, inside and out? How, is it like is it covered in sensors so you know where and when, or how are you measuring?
Well, you would be able to impregnate the cube with sensors, well, to a fairly low density because you still need appropriate combustion mechanics happening. The other sensors which would happen, I'm working on a design for a smoke detector, but an optical smoke detector which would measure the density, and building an array of lasers and photoreceptors on 2 planes would allow us to actually calculate where the smoke is and how it's emanating from the cube in low ventilation environments in zero gravity, as well as thermal imaging cameras, regular cameras, and gas sensors, of course.
So if this technology is validated, let's say we fast forward a few years from now, how is this going to pick up smoldering fire in a bigger, larger volume and environment?
Well, right now, one of the biggest impediments to detecting a smoldering fire is that it is so poorly understood. We don't understand smoldering fires. So if we understand how they behave, especially in zero-gravity environments, or on Earth, in our gravity, so where you have convection mechanics, then we would understand where sensor placement is important and which things to look for out of the fire. Thank you.